To output the data from your flow graph, you will need to add an audio sync block to your workspace. This block is responsible for playing the audio through your computer's sound card, allowing you to hear the broadcasted sounds. Now here's how to set it up. We will place the block into our workspace. I will set the sample rate. We'll double click the audio sync block, and in the properties window, we will set the sample rate to 32,000, which is 32 kilohertz. Now, most computer radio hardware supports the 32 kilohertz rate. However, if needed, you can tweak the flow graph to select a different sample rate. Now, we will connect the output of the rational sampler block to the input of the audio sync block, like this. By setting this up, the audio from your flow graph will be output through your speakers, allowing you to hear the domain-related signal in real time. Now, let's address one last detail. We will adjust the sample rate for the flow graph. So you may have noticed that most blocks in the flow graph have a sample rate property to 32 key or 32,000. This value corresponds to this sample rate variable, which was defined at the beginning of the project. You can modify this variable to affect the sample rate for all blocks that depend on it. Double-click on the variable block with ID sample rate, and we will change its value to 400 kilohertz, 400 E3. And that's it. After making this change, you will notice that the sample rate updates through your flow graph, impacting the sample rate for all blocks, except this final block. This is a great example of how adjusting a single variable can propagate changes through the entire flow graph design. Now it is time to run the flow graph. To do so, we will simply click the play button, and once executed, you will begin to see some text scroll by the console. After a few seconds, you should hear some music. It might come with a bit of static, as is typical with AM radios, but you should clearly hear voices and music. The audio will loop after a few seconds because the file source block is set to repeat and it doesn't contain much data. So if you don't hear anything, double check your computer speakers to ensure they are properly adjusted. Let's stop this. So if you notice choppy audio, and if you're running GNU Radio Companion in a virtual machine, you may need to tweak the audio sync properties. So open the audio sync properties window and change the device name to sys default. So if you're not using a virtual machine, however, changing the setting isn't recommended. So earlier in this project, we discussed how you can modify the key to graphical user interface entry values while the radio is running. However, if you want to change an ordinary variable block like a sample rate, you will need to stop the flow graph, adjust the value, and restart the flow graph to apply the changes. Now let's experiment with tuning to different radio station in the execution window. Okay, we had the problem here. Let's change. Okay, now let's again here. So here we will change the value, the frag here to 750 kilohertz. 1, 2, 3. And after a brief moment, you will hear a different repeating chunk of audio. That's because you tuned into a new radio station. So you can also experiment with other stations by setting the frequency to, for example, 710 or 750 again, as well as a few weaker ones like this. In this section, you've successfully built a simple AM radio receiver using GNU Radio Companion. So before we dive deeper into the mechanics, let's take a moment to peel back the layers of your radio design and look at the big picture. At a high level, your AM radio receiver flow graph accomplishes the five main things. It injects pre-recorded radio data into the flow graph. It tunes to a specific AM radio channel while filtering out the other channels. It demodulates the signal of the desired channel. It performs resampling on the signal to match the audio playback requirements, and it plays the resulting audio through your computer speakers. As you go through this project, you may have a few lingering questions. For instance, how does a filter work? What does it mean to resample? And how does multiplying a radio signal by sinusoid help in tuning? Like with this, remember? So these are crucial questions that you will explore in the upcoming sections. By answering them, not only will you gain a deeper understanding of how your AM radio flow graph works, but you will also uncover some critical radio concepts that will prove valuable as you continue your journey into the world of software-defined radio. My name is Typhoon, and I'm waiting you in next section.